So now we start into exponential functions, and exponential functions are functions where I have a number base and the variable is in the exponent. Now, we usually only consider positive numbers that are in the base. Um, because when you start getting negative numbers in the base, then you start dealing with what we call alternating functions, and those are a little bit more difficult to deal with. But generally, it's the exponential function is just having the x in the variable in the exponent position, and you have a number in the base position. Now, I'm not going to go through all of these things in detail because these are all things that are in your textbook, but I just want to hit on the highlights of a few things dealing with exponential functions. So here they kind of show you how to go about evaluating an exponential function. Along with that, keep in mind that as you see here, in particular, if I raise something to the 0 power, that is the same thing as getting 1. And that's going to be true for any base. Okay, so if I raise it to the 0 power, it's going to be 1. So basically, they're comparing the functions together here. But one of the things that we want to look at here is an exponential function is of the format f of x equals a to the x power for any positive base a. We always take the base to be positive because for we want a positive constant there, because if it's negative, certain powers, certain values for x, are going to make it positive. Some would keep it negative, and then some of them wouldn't even exist at all. So, and in general, for an exponential function, exponential functions, if you have it in the form y equals a to the x, if it's more than 1, it's a growth function. So populations and things will grow, or whatever the case may be. If the a value is less than 1, it's a decay function. If the base a is 1, then it's basically just a horizontal line, and it's just y equals 1 at that point, and it's really not an exponential function anymore. So let's look at an example about how we can go through and evaluate these exponential functions. So for example 1 here, we want to be able to graph these things. Now, as I mentioned before, 3 to the 0 power and anything to the 0 power is just 1. So this answer here is 1. Now, of course, 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. When I have negative exponents, kind of coming back to some rules we talked about before, negative exponents mean reciprocal. So basically, 3 to the negative 1 power is going to be 1/3. To the negative 2 power, I'm going to take a reciprocal of 3 and then square it, or basically I'm taking the reciprocal of this guy down here. So I'm going to have 1/9. And 3 to the negative 3 power would be 1/27. So if I started plotting these, 3 to the 0 is 1, 3 to the 1 is 3, 3 squared is 9, 3 to the third is 27. And of course down here I would have 1/3. And these are pretty close to the x-axis. Now the thing about this you want to keep in mind is that since it is a positive number, no matter what I do and what power I raise it to, it's never going to equal 0. It's never going to be negative. And you can see it's approaching 0. And if I have a really large negative value for x, I'm going to end up having a number that's really close to 0. So I'm going to be approaching it. I'm just never going to actually reach it. So one of the key characteristics of an exponential function is that it has a horizontal asymptote, but unlike rational functions, it's going to only have it on one side. Now, y equals 3 to the negative x power. There's different ways they present decay functions, because this is the same thing as y equals 1/3 to the x power. All the negative in front of the x is doing is basically taking anything that's negative here in this table, making it positive. So basically, in this table here, you're going to kind of see a reversal of the things you saw before. Please just make sure that when you see a negative exponent, don't think it's going to make the number negative. I still have a lot of students that do that from time to time. It causes them a lot of difficulty. So, and then if I plot those points, generally I have a graph that looks like this. It's a decay function. So be on the lookout for different ways, especially for decay functions. Sometimes they might put a negative on the exponent of x. Sometimes they'll just present the base as a fraction power that's less than 1. There's different variations they could do for that. So to give you some assistance with this, I want you to try this next problem where you're asked to complete the following tables. So if you could complete the following tables for A, B, C, D, E, F, and G. I'll pause a moment to let you do that. Okay, so getting back to the problem now. So A, B, and C are in the y values for the table y equals 3/2 to the x power. So here I had to kind of get an idea of what's going on. So for A, well, I'm taking 3/2 to the negative 2 power. Well, I can get rid of the negative by just doing a reciprocal in here. And then I'm going to square the top and bottom. And I would get 4/9. So it's reciprocating and squaring, so that's why the answer I get is 4/9. For x value of 0, as I mentioned before, and one thing you need to make sure you're always aware of, anything to the 0 power is just 1. For C, 3/2 to the 3rd power, well, that just means I'm going to take 3/2 to the 3rd power, which is taking this to the 3rd power and this to the 3rd power, and that's going to give me 27/8. We're basically the reciprocal of what I had up here. For 3/4, if I take 3/4 and raise it to the negative 3 power, I'm going to have, again, the reciprocal raised to the 3rd power. So the result of that is 64/27. For -1, well, -1 just means take the reciprocal, so the reciprocal of 3/4 is 4/3. Much like it was in the other table and anything I've mentioned so far, 3/4 to the 0 power, like any other number to the 0 power, is just going to be 1. And then 3/4 squared means I'm going to square the top and the bottom, so I'm going to get 9/16. If you have any further questions on this example, please feel free to contact me or ask about it in class. I'll see you around.